To use function notation. So function notation, you've typically been introduced to a y equals mx plus b function, some type of y equals. Well, y is the same thing as f of x. So another way we could write this is f of x equals mx plus b. Y and f of x are the same thing. This just falls under function notation. The reason it's nice is because it tells you it's a function and x is the dependent variable, so it's a function of x. That's how this is read. So if I was given, for example, that I have this function of x that is equal to 4x plus 2, what I can do is then tell people what values I want to input for x. So say I want to know what happens when x equals negative 2. Well then, function at negative 2 is equal to. So what this means is, instead of x in this equation, we're going to plug negative 2 in for x. So we get 4 times negative 2, what do we had for x? Plus 2. So the function at negative 2, plugged in for x, is equal to negative 8 plus 2, or is equal to negative 6. So function applied at the value of x equals negative 2 is equal to negative 6, and we've used function notation. Say, for example, we're given the function f of x equals 2x squared minus 4x plus 1. Then function at negative 2, say we want to know the same value for x. For every x, we're going to plug in negative 2. So we get negative 2 squared. Key thing, if it's a negative, you really want to focus on writing in parentheses so that the power will apply to the negative symbol as well. If you stick it in your calculator without putting it in parentheses, you'll actually get the wrong sign depending on what the power is. Plus 1, so we put negative 2 in for both the x's. So f of negative 2 is equal to 2 times negative 2 squared. So negative 2 times negative 2 is 4. Negative 4 times negative 2 is positive 8. So f of negative 2 applied to this function is equal to 8 plus 8 plus 1. So that makes a total of 17. So the same idea, say for example, I'm given that g, the function g of x, so this is the same thing. You can actually use different variables. What all it means is we have some function we've defined, and x is the variable that's dependent, or excuse me, independent. Independent, this is your dependent variable, independent, in the function. So we could have 8x minus 5, and say I want to know what g of a minus 2 is. So, same idea, even though it's not a single number we're trying to stick in, we actually can pull out anything into the function. This tells us what we're plugging in. And we're going to replace x with this. So instead of x here, we're going to write a minus 2. So I get 8 times a minus 2 minus 5. Distribute in that 8. So I get 8a minus 16 minus 5, which becomes 8a minus 21. So g of a minus 2 is equal to 8a minus 21. We can do the same thing given, say, a list of points. So if I'm given, for example, that my function is equal to this list of points, negative 5, negative 1, negative 3, 2, and negative 1, 4, then this function, say I want to know what f of negative 1 is. Well, if I look in the x value, so these are xy points, I look for negative 1 for the x value. The y value that goes with it is 4, so f of negative 1 is 4. Just like f of negative 2, looking through the x values would be here, is equal to 2. So what this means is if I plug in negative 5 for x, I get negative 1 for y. So you can do the same thing given a list of points.